This process is rather complicated, but bear with us. Let's use the luminance component image as our example. But know that the same process happens with the two chrominance components. The first step is to divide the entire image into 8 by 8 sections called blocks, each with 64 pixels with values from 0 to 255 that represent the luminance at every pixel. Next, we shift each value by subtracting 128 from each value, so the range becomes negative 128 to 127, where negative 128 is black and 127 is white. The next step is complicated, so let's start with an analogy. Pretend you have a painting that you want to recreate, and you only have a dozen different colors. In order to recreate this painting, you'll need perhaps 15 parts of the first paint, and then 3 parts of the second paint, followed by 8 parts of the third paint, all the way up until you use perhaps 11 parts of the last paint. And in the end, we have recreated our original painting. The discrete cosine transform works kind of like this. However, instead of paint, we use these 64 base images. And just like in our analogy, we can rebuild any block of 64 pixels using a combination of these 64 base images, with each image multiplied by a value or a constant saying how much of that base image is used. Thus, this 64 pixel block, each containing a value, is transformed into 64 values or constants that represent how much of each base image is used.